How do you configure a network interface? How you can quickly check the connectivity between two different hosts? What tools you can use to diagnose and troubleshoot networking connection? By the end of this episode you will have all the answers and much more. Today's episode I have prepared a list of the essential Linux networking commands that every DevOps engineer should know, because networking is really the essential and such a crucial aspect of a DevOps job, starting from the server configuration to network troubleshooting. Hello, my name is Simon and welcome to NetCafe. In this channel we talk about the DevOps, cloud, networking and cybersecurity. So if you are interested in this type of topics, consider subscribing. Tool number 1, ifconfig. Networking forms a backbone of the modern infrastructure, enabling communication between servers, applications and services. As a DevOps engineer, understanding how to manage and troubleshooting network configuration is very crucial. So let's start with the very fundamental command, which is ifconfig. And this is really a very traditional tool and one of the first one that you learn on your way to DevOps position. Let's see what we can get from this command. Let's run with the Ethernet 0. So let's break it down the information provided by the command for the network interface Ethernet 01. So the first thing, as a general information, we have of course the name of the interface, hardware address, also known as a MAC address, and this one is unique to the network interface. It can be used to communicate within our local network segment. Then of course we have a layer 3 IP information, IPv4 address assigned to the interface. We have a broadcasting address that is used when we want to send the information to all of the devices in our network and in our subnet. Of course we have a mask that indicates what is the portion of the host and portion of the network. On top of that we also have provided IPv6 that is assigned to our interface. When we look at the interface status, we have information that indicates that interface is ready to use. This is up. We have information about broadcast, running and multicast. Starting with the broadcast, that really indicates that the interface allows us to send data to all of the devices. Running, saying that the interface is operational, and multicast allows us to send the data to multiple specific hosts. We also have additional informations such as, for example, MTU, which is the maximum transmission unit. This is the largest size of the packet that can be sent in the transmission. So we have the packet information. We can see how many packets are being received, what is the number of errors, packet drops, receive overruns or number of frame errors. This command will assign the IP address to the virtual interface Ethernet 0:0, which is an alias for the main Ethernet 0 interface. So once we done that, we can also run ifconfig, which is indicating that the IP address was assigned successfully to our virtual interface. So this is first and a very basic and traditional, I would say, network connectivity tool. Second tool, ping. Network configuration is a complex topic and unfortunately not always things go accordingly to our plans. So this is why we have tools such as, for example, ping, traceroute, tracepath, netstar or TCP dump that can help us to troubleshoot the network. The most basic utility is of course ping, which sends the ICMP packet to the system you name, for example IP or hostname, and then we wait for the reply. In Linux, ping continues to send the package every second or until we interrupt with Ctrl+C. We can also specify limited number of the tests with -C and the specific number of the package. So in this case we can, for example, run ping-C4 and then some specific IP address, and we can see that the ping was successful. We can also run another test. Let's use some other host name that is not existing, and we can see that there is no connectivity. Tool number 3, dig. In Linux, dig, which stands for Domain Information Grouper, is a command line tool used for querying the domain name system or DNS servers. So it is primarily used to diagnose and troubleshoot DNS problems by retrieving information about the domain names and their corresponding IP addresses, DNS records and other related data. We can run this quick example here. The dig command that we provided shows a successful DNS lookup. Let's break it down. So as a first part, we have a header section. That part really shows us the version of dig and the commands that being used. Then we have a query response. It's a standard query. Then we have a no error that indicates that the query was successful. We have the identifier of that query. We also have some flags, which is a query response, recursion desired and recursion available. We also have something called pseudo section, and here we can see, for example, the maximum UDP packet size or the eDNS, which is the extended DNS options. Then we also have question section, so this is where we can see that the query object was the A address record of the google.com, and then the most important one is the answer section. So here we can see that it lists the IP addresses associated with the google.com, and we can also see TTL, which is time to leave, and for each of the records is the same number, is the same amount of the second that indicates how long the information can be cached. And then we also have a query time. We can see that it took 0 milliseconds to complete, indicating that was very fast. We also have the used server, so the query was resolved using the local DNS resolver, which is 127.0.0.53, which is a systemd resolve service on Ubuntu. Then we also have a query time and data, message size. So we can see that this is very powerful tool when it comes for the DNS troubleshooting. We can also do reverse DNS lookup with that tool that finds the domain associated with the IP address. Tool number 4, which is TCP dump, and this is a very advanced solutions used for the network diagnostics, and that functions, TCP functions as a packet sniffer, which means that it intercepts and displays the network packets in the real time. Packet sniffer serves as a crucial diagnostic tools, allowing engineers to confirm network data receptions, delve into the raw data and precise protocol analysis. This capability is indispensable for intricate protocol implementation issues. We can see in TCP dump manual that we can have quite a few options on how do we want to use this specific tool. Let's see some basic usage. So for example, we can capture the packets on the specific interface. So we can run TCP-Ethernet 0, which is the name of the interface. We can see that I'm running in a root because the ordinary users aren't allowed to run this tool. Once it runs, TCP dump begins to printing the lines for each of the packets it monitors. Some of the lines can be quite long, and so it also take more than one line to display. This line include a timestamp, a stack identifier, IP in all of these examples, the original system name or IP address and port, and of course the destination name with the IP and port for the packet specific information. Another very interesting use case for TCP dump is the running, capturing only TCP packets on our interface. We run TCP-I, name of the interface, and TCP. Each line starts with the timestamp indicating the time when packet was captured. We also have the source and destination, just like in the previous example, and we also have something called flags, and that indicates really the status or type of the packet. There are some S flags, S dot flags, just dot, which stands for acknowledgement flag, push data, which indicate the push of the data and acknowledgement. Then we also have a window size that indicates the size of the received window for the flow control. We can also run with port 53, which will capture the data on DNS queries and responses. So these examples really shows versatility of the TCP dump tool and its ability to capture, analyze and filter network traffic for various purposes. Tool number 5, Netstat. Another very useful diagnostic tool is Netstat, and this is Swiss Army knife when it comes for the network tools, because it can be used in the place of several other tools depending on the parameters that we are passing to utility. It can return information that are not really easily obtained in the other ways. Some examples can include, for example, netstat-a, and this command will display all the active connections and listening ports both for TCP and UDP protocol. The exact output can of course vary depending on the system and current network activity. So we have a proto, which stands for protocol that is being used, TCP or UDP. We can also have the local address, we have foreign address, so we can also run netstat-r, which displays the kernel routing table, which includes information about how packets are being routed through the network. The output typically shows the destination network gateways and other network interfaces being used, and here is the example of how the output might look like. So we have a destination network or host, we have a gateway. Then moving on, we have a netstat-s, and that commands provide a detailed statistic on the network protocols, including information about how packets are sent and received, errors, and other very much relevant metrics. This can be used for diagnosing network problems and monitoring network performance. Moving on, we have a netstat-l, which is used to display all the listening sockets on our system. This includes both TCP and UDP sockets that are in the listening state, meaning that they are waiting for incoming connections or datagrams. This is also how the output might look like. We can also run with -t, which stands for TCP, that shows only TCP connections. Netstat is a valuable tool for network and DevOps engineers for monitoring, troubleshooting, and securing network infrastructure in the modern IT environments. Understanding its output and how to interpret network data is really essential for effective management and optimization of our infrastructure. And well, that will be all for today. Thank you very much for watching, and if you like this video, please remember to subscribe and give the thumbs up. Thanks.